So let's look at this ETLS process from beginning to end. Now, first off, you'll notice that we have an open authentication taking place here. We have the start request that lets everybody know, hey, I'm using 802.1x. I have that in play here. So this is what I'm using. Now remember, everything's set up for ETLS here. If something was not set up for ETLS, this would not work because we have ETLS set up on our Radius server. We have ETLS set up on our clients. So that's the authentication process we're going with. We must agree on that before anything else. So we've agreed on ETLS. So what happens is start. We're going to send this up to the access point. The access point is going to look at it and say, okay, we're using 802.1x. It's going to pass that along to the authentication server. The authentication server is then going to send back the request identity. Who are you? Then the supplicant or our wireless client that's trying to authenticate is going to send up its identity. Now, once that takes place, the authentication server finds out who are you. If that is valid, guess what happens? The server then sends down its server certificate. What is the server certificate? Well, if you remember, that's the server's public key. And then the client sends up its certificate. What is that? That's the client's public key. Now remember, when the server certificate is sent down, that has the stamp of the CA approval, the certificate authority. And then when the client sends up its certificate, that has the seal of approval from the certificate authority. So once we've done that, see this is open. Once that open is done, then we have a tunnel, a secure tunnel that we can transmit data in. That's when we exchange our public keys to each other. That's when we have an encrypted exchange. Now, this encrypted exchange gives us our random session keys. This gives us our pairwise master key or PMK. This is a symmetric key. That means up here we were exchanging what? What were we exchanging up there? We were exchanging an asymmetric key up here. Okay, so let's look at this process again. Open authentication first. What's open authentication was okay. We have a tunnel established. What we're going to do is exchange keys. Both our public keys are going each way. These are asymmetric keys. There's a public key that the client gives out, but it maintains its private key. The server has a private key and sends its public key out. The client sends information using the server's public key to encrypt it so no one can read it but the server. The server has the private key to decrypt that. Vice versa, the server does the same thing with the client's public key. Anything it sends, it encrypts with the client's public key, and the client can then decrypt that data with its private key. So we've used asymmetric keys here at this level, but we're not done yet. Remember the implication with asymmetric keys. It is very, very CPU intensive, a lot of mathematics involved because we're not using the same process to encrypt and decrypt. So we can't do that, right? We can't do that just to send data from our access point to and from our access point. That doesn't make any sense. We can't utilize all the CPU resources here. That would severely cut down on the number of clients our access point could manage. So what we're going to do is we're going to use asymmetric keys to establish authentication. Once we establish authentication, we'll again use those asymmetric keys to send out a symmetric key or session key, randomly generated. And this session key is going to be sent out to the access point, and then it's going to be sent out to the supplicant using an encrypted connection, using this asymmetric tunnel we set up. So now we have a symmetric key that's sent, and now we have our key management taking place on our supplicant and our access point, and we have a protected data session using those symmetric keys. And because this symmetric key is temporary, only used for this session, the next time we connect up, another one's going to be generated randomly. It is not that much of a security risk because it is a temporary key. It's only used for that particular session. So this is how ETLS works. We start with an open connection. We create that secure tunnel to exchange keys, to get that asymmetric key exchange. Then when we have that, we have a new encrypted tunnel, this asymmetric encryption, to do what? To exchange symmetric keys. This is that pairwise key. And remember, the pairwise key is not only given to the supplicant, but the access point. Once we do that, now the supplicant can use its pairwise key to send encrypted data, and then the access point can use the same key. Remember, this is symmetric now, to decrypt that data. Because it's symmetric, it's much faster and can be done on a packet by packet basis. So what have we done? We've secured our wireless data by encrypting it with this pairwise key, the symmetric key. But we had to use this ETLS process in order to get that key. That's the whole point of the ETLS process, was to get the pairwise master key without anyone else being able to get it or read that information as it was sent over wireless. That's why we took all these different steps.